Hello once again, everybody, and welcome back. We're on to question number 16 on the 2000 Pascal paper. So what does question 16 have for us? The area of square ABCD is 64. The midpoints of its sides are joined to form square EFGH. The midpoints of EFGH are J, K, L, and M. Okay. The area of the shaded region is, alright. So it looks like the shaded region is going to be the area of the smaller square, EFGH, and then we subtract off these small triangles. That's the way I would approach it, because I don't think there's really an easy way to get to make this shape. But we can subtract off these smaller triangles from squares and right angle triangles, much easier to work with. Alright, so area of square is 64, and that means that AB, these side lengths, AB, AD, DC, and BC, are going to be 8. So that tells me what AF and AE are, and so I can figure out the length EF, and a whole bunch of other stuff. Okay. So let's draw ourselves a large picture. I'm going to need more space than what I have left here, so I'm going to flip the page. I think my diagram is getting out of hand because it's clearly not nice, clean, and square. We'll put a right angle here just to make sure. Alright, and let's label things just to keep it all nice and neat and clean. C, D, and then what was it? I think it was E was here, F, G, H, I think it was I, J, K, L, but let's double check. Oh, J, K, L, M. I don't see why there isn't an I, but okay. Everything else was properly labeled. So for some reason there's an M in here. Okay. So an area of 64 means side length of square root of 64, but that's just 8. Okay, so BC is 8. 8. So since E, F, G, and H are midpoints, then we see that AF is equal to FB is equal to BG is equal to GC, CH, HD, DE, EA. It's going to be 1/2 of the side length, 8, so that's going to be 4. So for example, each of these guys in here is 4. Okay. So we have a right angle triangle here. So we know the sum of the squares of the legs of the triangle are going to be the hypotenuse. So by Pythagoras, we know that EF squared is going to be the same as AF squared plus AE squared. 4 squared plus 4 squared. So EF is going to be square root 4 squared plus 4 squared. Well, what's 4 squared? 16, so 16 plus 16 is going to be square root of 32. Or another way to write that, we can take out, let's actually do the calculation. We can write this as 16 times 2. And square root signs distribute over multiplication. And square root of 16 is 4. So EF is 4 root 2, and EF is equal to FG equal to GH equal to AH, or EH, which is 4 root 2. Okay, so now we have the side length of this square, and so we know what the area of EFGH is going to be. It's going to be 32. Okay. The J, K, L, and M are midpoints. So, just as we had before, we're getting at a bunch of equal lengths. KG, GL, LH, HM equals ME is 1/2 of the side length EF. So that's going to be 2 root 2. So right in here we have 2 root 2, 2 root 2. Okay. And that's enough to solve the problem. So the shaded region is EFGH minus triangle JFK minus triangle LHM. Okay. But we know EFGH is just going to be the square of its side length, which is 32. And each of these triangles, where they're the same triangle, and they're 1/2 base times height. Now, if we look at this sort of on the side, we tilt our head, we see LH is the base, MH is the height. So base times height, base times height. And we're going to have another one of those. Base times height. And we're going to have to finish this on the next page, but that's okay. So it's going to be 32 minus 1/2, 2 root 2 times 2 root 2. That's going to be 8. Minus 1/2 of another 8. So that's 32 minus 4 minus 4. 32 minus 8. And that's going to be 24. So that's the area of the shaded region. Took us a while to get there, and we see our answer is B. As I say, it took us a while to get there, but I would say every step was fairly straightforward. What did we do? We found the side length of our big square. We used that to find the side length of our smaller square, and we used those to find the side lengths of the smaller right-angled triangles. And we realized shaded region is small square minus these two triangles. So I would say ultimately it was straightforward, if not a bit computationally expensive. All right. So that's, what was it, question number 16, I think? Question number 16. So in the next video, we'll take a look at question number 17, and I do hope to see you there.